Hey guys, hoping all is well with everyone. So in this video, we're going to be looking at our question of the day that looks at simplifying the expression that you guys see on your left, which is going to be 12p cubed plus 48p squared all over 6p squared. So this question would revolve around 8th grade math and simplifying expressions, and more specifically rational expressions. So with my videos, my goal is to always kind of show you guys kind of a step-by-step breakdown to solving these problems. And sometimes there are multiple ways that you can approach them. And this case is no exception. So this is why I really liked this problem, because there's two main approaches that you can take. And remember that approaching it is all based on your comfortability. But that being said, you can take these methods that have an individual approach based on their own properties and attributes. So the first method that we're going to take with this problem is going to be the method of based on the principles of greatest common factor. So when we look at this expression, we're going to go ahead and start by just kind of copying the expression here. So we have 12p cubed plus 48p squared all over 6p squared. So the strategy with the greatest common factor is to determine a factored form of the numerator that hopefully with a greatest common factor will have some common factors with the denominator, so we can cancel out or potentially even eliminate the fraction or rational component of this expression. So when it comes to factoring, one of the strategies I personally like to take is the idea of factor trees. I used them in my previous video to determine a greatest common factor to simplify a fraction to its reduced form. So here they're really helpful because when you do a factor tree, you're breaking down the term into its prime number and variable components, and that really allows you to stay organized and with the bookkeeping and see all of the terms structure right in front of you. So if you're not familiar with factor trees, there's other phrases and names for them, but basically what it does is it takes a term and breaks it down into its prime number and variable components by kind of like division. But first thing I'm going to do is I'm going to represent 12p cubed as 12 times p cubed. So then I basically just kind of break this down. So this is going to just be p times p times p. It's kind of like you're making little branches. And then 12's prime factorization, we're going to start with 2. Now, some students will just try to break the number down by making it smaller by any means. Some will kind of chip at it, like this method here, where you just use smaller prime numbers that the number is divisible by to kind of see the smaller factors that make up its structure. So 2 times 6 is 12. Break that down, and then 6 is just 2 times 3. So when I do these, I personally like to draw circles around the prime factors just so they don't get confused with what could be with other factors. So remember, by definition, a prime factor is a value that is only divisible by 1 and itself. So we can go ahead and list the prime factors for 12p cubed here, which is going to be 2 times 2 times 3 times p times p times p. Okay, so now you have a really nice outlook of every factor that makes up, that makes up 12p cubed. Now let's do the same thing for 48p squared. So 48 and p squared. This is just going to be p times p And this one's going to be a little bit more involved, but not too bad. This is going to be 2 times 24. This is going to be 2 times 12. And as you guys can see, there will be some type of greatest common factor here, because we're already seeing that there's a factor of 12 existent in 48p squared, which makes sense. Perfect. And then we'll go ahead, same thing as before, we'll go ahead and circle these. Now again, you don't have to circle them, but again, I think it really allows you to stay nice and organized, just to make sure you're not accounting for any non-prime factors. Okay, so then we'll go ahead and do the same thing as before. This is going to be 2 times 2 times 2 times 2 times 3 times p times p, and there we go. So, and then we're just going to make sure, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48, times p is 48p squared. So now what we're going to do is we're going to go ahead, and because we can directly compare these, we can see exactly what their greatest common factor is. So remember, we can only use one factor from the prime factorization once. And then we're going to see which ones are in common here. There, p and a p there. Perfect. So now we can see that there's a 2 and a 2, a 2 and a 2, a 3 and a 3, a p and a p, and a p and a p. Now this p here is going to be remaining in 12p cubed because there's no other factors of p in 48p squared that I can share it and contribute it to my greatest common factor. Likewise with the two factors of 2 here in 48p squared. So my greatest common factor is going to be the product of all of those factors that are in red for either of the two terms. So 2 times 2 is 4, times 3 is 12, times p is 12p, times another p is 12p squared. So now what we can do is go ahead and start formulating our factored expression, which is going to be 12p squared. And then again, the beauty of this factor tree method is because now that you've contributed to what is your greatest common factor, you can now see what remaining factors are left that you can put in the parentheses based expression. So out of 12p cubed, if I extract a greatest common factor of 12p squared, all I have left is one factor of p. And then with the 48p squared, if I factor out a factor of greatest common factor of 12p squared, all I'm going to have left is two factors of 2 or 4. So it really helps with staying nice and organized, and allows you to really stay on top of where all your factors are going, whether they're being part of the greatest common factor or what's left. And the reason that this is important is because now we can see if there's any possible elimination that we can make with our original denominator. Now keep in mind, with the 12p squared, it's being multiplied by that quantity of p plus 4. So that is going to give us the opportunity to use division with our denominator to see if there's anything possible that we can eliminate. Now, if we do 12p squared over 6p squared, what's going to happen is that the p squareds are going to cancel out. And then if we eliminate 12 over 6, that's going to reduce to just 2 over 1. So now we've pretty much eliminated the entire denominator, because what we have left is going to be 2 times the quantity, p plus 4, all over 1, and then that can reduce to the factored expression in simplified terms, 2 times the quantity p plus 4. So that is going to be our simplified expression, going to be 2 times the quantity p plus 4. So again, the goal with this approach is to determine some greatest common factor that you can use to potentially eliminate any components or structure in the denominator. Okay, so in this case, we were able to fully eliminate the fraction component of this rational expression. So again, this is going to be the method of GCF, or greatest common factor. So now let's go ahead and look at the second method. So this next method kind of is based on the principles of laws of exponents. So there we go. So when we look at this rational expression, we see that the numerator is composed of 2 terms that are separated by a mathematical operator, being addition. So what that tells us is that both 12p cubed and 48p squared share the denominator of 6p squared. So what we can do is split this rational expression into 2 individual fractions that are being taken the sum. So we have 12p cubed over 6p squared plus 48p squared over 6p squared. And then essentially what we're going to do is just use simplifying of rational expressions, implying or implementing laws of exponents when we need to. So the way I break these up is when it comes to simplifying rational expressions that are just single term over single term, is I break it up into see here. I break it up into its coefficient components as well as the variable components. So we have 12 over 6 times p cubed over p squared. This is going to allow me to simplify. So I'll start with the whole number. So 12 divided by 6 is just 2. And then, using your quotient of powers rule, remember when we have the base being the same of 2 terms that have exponents, this is going to allow you to subtract the exponents. But the biggest thing with that is always remember that subtraction of exponents when we are dividing is order specific. So we always have to do numerator minus denominator. So this is going to be 2 times p to the 3 minus 2, which is just going to lead us to 2 times p to the first, which is just going to be equal to 2p. Okay, and that's kind of really breaking it down, but just so you guys can see that when you have a subtraction that leads you to just a exponent of 1, you don't have to represent the 1 as its own exponent because it's inferred. Okay, and then for the and then for the 48p squared, we're going to do 48 over 6 times p squared over p squared. So remember, in these individual terms, being 12p cubed over 6p squared and 48p squared over 6p squared, everything is being multiplied. and divided. So we don't ever want to implement an addition or subtraction sign within a single term. So we're going to go ahead and do the same thing here. 48 divided by 6 is 8. And then we use our quotient of powers rule again. But when we break this down, what we see is that we get p to the 2 minus 2, which is going to implement another laws of exponent, which is going to be the 0 power rule, because this is going to be 8 to the p times 0. And then remember, with that 0 power rule, anything to the 0 power is 1. So that's just going to be 8 times 1, so that's going to be 8. And then what we do is, because these two terms simplified are added, we can go ahead and represent that as our final expression. So this would be the expanded form, so to speak, and then that will be our final answer here. And then if you wanted to factor it as we did previously, you can take out a 2, and that would give you p plus 4 for the factored form. Okay. Alright guys, so I know we kind of covered a lot of methods here with a lot of different properties, but I hope this helps you guys out, and if you have any questions, please don't hesitate to reach out and ask, but I look forward to seeing you guys in our next question of the day, and as always, please take good care and be safe. Bye.